Welcome to my channel Guys and Science, and my name is Syed Muhammad Saif, and today's topic is why the density of potassium is less than sodium, and not why the density of sodium is greater than potassium. That's because the potassium is the thing which changes the property and not the sodium. How the potassium changes its property, and it is the trend, why the trend, how the trend, and how it affects the body, it is permanent or not. Everything is there in this video, so stay tuned till last and let's start it. So first look at the periodic table and the group 1 alkaline metals. In the alkaline metals, the elements are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, where francium being radioactive, hydrogen being a gas. So therefore there is the main metals are lithium, sodium, potassium, rubidium, cesium. So only 5. So then when we took up the trend and see, density of lithium is less than sodium, density of sodium is greater than potassium, density of potassium is less than rubidium, and density of rubidium is less than cesium. All the trends are obvious except one, that is why the density of sodium is greater than potassium. In easy words, and the topic is of this video, why the density of potassium is less than sodium. First of all, let's take a look at the electronic configuration of both the metals. Sodium 1s2, 2s2, 2p6 as 3s1 and 3p0. So it completes the electronic configuration with only one electron in its outermost shell and orbital 3s1, and it's normal. And now the electronic configuration of potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d0. Yes, because of energy difference and the energy level of 4s orbital is less than 3d orbital, the electron goes in 4s orbital except by 3d orbital, and that makes all the difference. Why the 3d orbital is excluded? Some of you may think that it's normal. Yes, it is, but there are some tweaks in that. The tweaks are, when we observe the chemistry class 11th NCERT textbook, in the page number 60 or 50, there is a table in which it's truly seen that the energy difference between 4d orbital and 3d orbital and 4s orbital is extremely small. Extremely means extremely, and that means that the energy level doesn't affect much of the case, and it does so. The energy difference is so small that the small amount of energy from atmosphere or from anywhere could make the electron of 4s orbital to jump in 3d orbital, and because 3d orbital has more space, it could jump into any of the 5 orbitals which are present. Predominantly it jumps into any 2, that is dz square or dx square minus y square. That's natural because the 2 lies in the orbital position in any of the axis, and other 3 lies between the axis, that's in plane. Why does then it not affect so much? In short way, how that affect? The electron when goes from 4s orbital to 3d orbital, by change in some energy and some manipulations, because there are a lot of electrons, lot of atoms in that closely packed tight space, the lattice energy frequently changes, and that means some energy could be borrowed. The word has special meaning, borrowed from the atom, and thus some of the energy could be lost. The loss in energy could make again the electron to move from 3d orbital to 4s orbital. Thus the electron could jump from 3d orbital to 4s orbital and back again from 4s orbital to 3d orbital many times simultaneously in any way. that creates a equilibric jump position, and because of that equilibric jump position the volume of atom changes. And the volume of the atom, I means the apparent volume. When the atom is small, that's the electron is in 4s orbital, it's small, but when it had to go into 3d orbital the space should be maxed up. That's why there is some apparent volume vacuumed in the tightly closed packed lattice so that the volume could fit up nicely. Therefore there is some gap left by the atoms. That's not known how the atoms manage to do that. There is no driving force between them, but yet they do that. That's not known, but they do somehow make a gap, and thus when the electron grows in size the gap is fulfilled. Therefore the volume increases tremendously much faster. Yes, the volume increases going down the group, but it adds up an additional layer to the increase in volume, so the volume increases by a very large factor. And though the ratio of mass and volume is equal to density, density equal to mass upon volume, mass increases, volume increases tremendously, and therefore density not decreases tremendously because mass also increases, but decreases by a factor that it helps sodium to come out and have more density than sodium, but doesn't make it the lightest element in periodic table, or at least in alkaline metals. That is, the lithium holds the title of lightest metal, and after that potassium is the second lightest alkaline metal, and then sodium. It follows the order, and there is no exception except potassium in this table and no other element in at least alkaline metal group show this type of behavior anymore. There is a question in the mind, actually two questions. If the volume increases so much, then the volume should increase or decrease continuously, and thus the volume should change continuously. So if I take a sample from A sample and B sample, one from ore or other from anywhere, the density should be different. Yes, in fact that happen not only by sodium, potassium or any other metal, but also by iron and many of the metals that are mostly ductile or shows the so-called metallic character. That is the defects, Stockholm defects, many more defects, electron ion, many more defects make it to change its density, and the density of any two samples could not be 100% equal. That's why the density of any two metals from different samples could be different. But as per the change in the volume, that doesn't affect the density of the sodium that much, so that the density should be calculated to very sharp extent. That is, it doesn't affect much in the engineering cause or any other cause, that's by photoelectric effect or any cause, because in photoelectric effect atom jumps and the volume also increases, but we are not using both the applications, that is photoelectric effect and increase in volume, simultaneously in this process, so it doesn't matter anymore. And second question, since the potassium is the first to have a d orbital in alkaline metal group, then it should have, and also it is the first element in the periodic table to have a d orbital, and only inclusion of that d orbital, the electron is not even going predominantly in d orbital, it makes all the difference. So why didn't the other bottom line, at least alkaline metal, didn't affect that much at all? Here's the reason. The electron configuration of the rubidium is 1s2 and till up to s1 and 4d. The energy difference between s1 and 4d0 is extremely, not extremely, but significantly larger. so that doesn't make any effect, so that the electron should do equilibric jumps between the two, and also it doesn't affect the atom at whole because the distance and somehow the energy is also very different. And here also the energy difference is very small, so that the electron goes predominantly in 5s1 orbital, and in the case of cesium it goes in 5s1 and other orbital is 4f. The energy difference between 5s and 4f is also very large, so the large energy difference can not be underestimated, and because of the large energy difference, and it's very extremely large, not again small difference, it by no means it can't do equilibric jumps unless and until it close to its melting point, and after it's close to its melting point any metal will expand, and the effect will not add up so tremendously that it changes its volume solely due to that reason. And what could I say more? Make sure to subscribe, like and share this video, and that's for today. Stay tuned, be very safe.